Hello, let's take a look at your MT3, LT4 problems that you emailed me about. On the directions for problem 21, you're supposed to solve it by factoring. In order to solve it by factoring, you must make one side equal to 0. I like to keep my leading coefficient positive, so I'm going to keep the x squared positive. So let's move the 4x. So we'll subtract 4x from both sides. And we get 7x squared minus 4x equals 0. Now we want to factor this. What goes into both terms? Well, notice there's an x in each term, so let's factor that x out. So we get x times 7x minus 4 equals 0. Now we'll use the zero product property, because we know when we multiply two things that equal 0, one of them must be 0. Or in this case, both of them could be 0. So x equals 0, or 7x minus 4 equals 0. In the first problem, the first equation, you're done. X is 0. In the second equation, now we got a linear equation. Let's solve that. So let's add 4 to both sides. So 7x equals 4. Let's divide both sides by 7. X equals 4/7. And there are your two solutions for that problem. Taking a look at problem 22, we kind of do it the same way. First, make it equal to 0. So we're going to subtract 9x from both sides. So then we get 10x squared minus 9x equals 0. Factor it. Factor out your x. You got 10x minus 9 equals 0. So now we have x equals 0 or 10x minus 9 equals 0. Well, let's solve for x in the second equation. The opposite of subtracting 9, we're going to add 9 to both sides. 10x equals 9. Divide both sides by 10. X equals 9/10. So your two solutions are x equals 0 or x equals 9/10. Let's take a look at question 26. You have 36x squared equals negative 25. You start to do this problem by adding 25 to both sides. You've got 36x squared plus 25 equals 0. We run into a problem. We can't factor that, can we? Let's try looking at it from a different viewpoint. Since there's no x term, let's just take the square root of both sides. So then we get the square root of 36x squared is 6x. The square root of negative 25 is 5i because it's a negative. So we're going to go plus or minus 5i. Then we'll divide both sides by 6, and there's your answer. X equals plus or minus 5i over 6, or plus or minus 6i. We could have factored that with the i's, but I thought that would be kind of confusing for you to understand. So let's take the square root of both sides. Yeah, I pressed something by mistake there. Okay, question 30. Here we have an application. It says the length of a rectangle is 2 feet more than the width. Find the dimensions of the rectangle if the area is 63 square feet. So let's draw out a rectangle. And we're told that the length is 2 feet more than the width. In other words, we don't know anything about the width. I'm thinking I'm going to call that W. W for width. The length is 2 feet more than that, so we're going to say W plus 2. We know the area is 63. Well, we know from geometry, the formula for a rectangle, for area of a rectangle, is length times width. So now let's plug that in. So in other words, 63 equals the length, which is W plus 2, times W. So we get 63. Let's distribute. You get w squared plus 2w. We want to make it equal to 0 because we're going to factor it, so minus 63 from both sides. So then we get w squared plus 2w minus 63 equals 0. Well, that's a quadratic that we can factor. We'll make two parentheses. Since our leading coefficient is 1, we have w in front of each parentheses. I need two numbers that multiply to negative 63 but add to 2. Or in this case, since it's negative 63, they subtract to 2. Well, that's a common math fact, isn't it? 9 and 7 multiply to 63. If we make 7 negative, they subtract to 2. I know the bigger one has to be positive because my middle term is positive there, so I know my bigger term has to be positive. So w plus 9 times w minus 7 equals 0. So in other words, w plus 9 equals 0 or w minus 7 equals 0. So we subtract 9 from both sides. We get w equals negative 9. We add 7 to both sides. We get w equals 7. Now, these are the two answers to the quadratic, but they're not the answers to the problem because we're doing an application width of a rectangle. Can the width of a rectangle be negative? No, it can't. So this is a problem to the quadratic, but it's not a solution to the problem. So your answer is the width is 7. We want to find the dimensions. So we know w equals 7. So w plus 2 is going to be 7 plus 2, which is 9. So we know the dimension is going to be 7 by 9. And there were units on this one, so it should be feet. Maybe I should put feet in there. And that's how you do that problem.